Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are starting with the P3 session, the 360 degrees syllabus overview. And this is day one. And we are starting at, let's say, 7:51 p.m. Pakistan Standard Time. So let's get started with the idea of reviewing P3. So now I'll try to complete half of P3 today, half of P3 tomorrow. Of course, the focus will be on major topics. It is an overall syllabus overview. So now, day one, it will be focus on algebra, logs, and indices. And then it's about the third one, that is trigonometry. The fourth one, that is differentiation. And the fifth one, that is integration. And maybe differential equations. So the major topic will be this one, which is differentiation, integration, trigonometry. And I'm just looking at one thing that is over here. Okay. So now this one. Okay. So just double checking. So these are the three major topics that I'll be focusing on. And naturally, the focus will be on trigonometry also, a little bit of logs and indices, little bits of algebra. So now let's get started one by one. And from here, let me first start with this thing. That is modulus. That is one thing. Partial and binomial. This is also part of algebra. Polynomial. Then logs. And then trigonometry. Okay. So now, first of all, when we talk about modulus, let's just talk about modulus first of all. That is, in modulus, we know that the modulus, the magnitude of a positive value is positive. The magnitude of a negative value is also positive. The magnitude of zero is zero. So positive remains positive. Negative becomes positive. Zero remains as zero. That is the basic idea. How we get started? If we are talking about modulus inequalities, case number one, there is modulus on the left-hand side, lesser than or equal to a. When I expand it, this is what it becomes. And why it becomes like this? Because if I say modulus of x equals to a, maybe x is positive equaling to a, maybe x is negative equaling to a. That means x equals to a, therefore x equals to negative a. Similarly, if we have this idea, so we say that modulus x less than or equal to a, x is positive less than or equal to a, x is negative less than or equal to a. Therefore, this becomes x is greater than or equal to minus a. We draw them on the same number line, and this is what we get. This is the result. So case one will be opened up this way. For example, modulus x less than or equal to 4, x lies between negative 4 and positive 4. X plus 1 modulus is less than 3. X plus 1 lies between negative 3 and positive 3. So now over here, some people are asking me how many past papers would be enough. I think it would be better if we just focus on this thing right now. That thing I can answer it later. And maybe within the stream, I'll be answering that. So there is no absolute answer for that. So let's not get distracted. Otherwise, I won't be able to teach you properly. You won't be able to understand it well. Okay, so let's focus over here. Similarly, if we have something like this, 2x plus 3 modulus is less than x plus 1. Therefore, 2x plus 3 lies between positive of x plus 1, negative of x plus 1. And now look at the working. You have to do these two things separately. Now, when you expand these two things separately, how do you proceed? So now this side, that's the red side. So 2x plus 3 is lesser than x plus 1, make x the subject. Over here, minus of this thing, you expand this part, is lesser than 2x plus 3, and then x is greater than minus 4 over 3. So now, when you want the final answer, what do? Have a good look. Then you plot them on a number line, and it so happen they are both going their own ways. This is going to the right, this is going to the left. There is no overlapping region. So therefore, this is the answer. This is the answer. This is the answer. That is the final answer from here. Similarly, when we talk about case number 2, we have this thing. Modulus of x greater than or equal to a, that becomes this thing. X lesser than or equal to negative a, x greater than or equal to positive a. So now examples of case 2. Modulus x greater than or equal to 5. So x is lesser than or equal to negative 5. X is greater than or equal to positive 5. 2x plus 3 modulus is greater than 7. Therefore, this thing is greater than 7. That is this part. This thing is lesser than negative 7. That is this part. So again, there are two options. There is this option, and then there is this option. Now, this option is giving me x is greater than 2. This is giving me x is lesser than 5. And there is no overlapping region. That is the answer. Now, here is the idea of quadratic inequality. We want the factorized form of quadratic equation. It is based upon the roots. Sketch based on any factorized form. Write inequality by looking at the sketch. So this is like drawing a sketch. X plus 1, x minus 2 is greater than 0. And then what have I done? I have jotted down the roots. The shape of the curve is positive, and the region below the x-axis is one single region, one single answer. Therefore, x lies between -1 and +2. That is how this thing is done. Now let me just do one thing over here. So this one, and let me just. Okay. So now that is how you get this answer. What about something like this? X square minus 5. Yes, the answer could be in the third form also. X plus root 5, x minus root 5 greater than or equal to 0. Two separate region, two separate answer. That is how you write it. Now, why have I revised this thing? Because for case number 3, when there is modulus on both sides. So now what we do is that we square both sides. Positive remains positive, negative becomes 0, 0 will remain as 0. It might turn out to be a linear inequality. It might become a quadratic inequality. If it's a linear inequality, basic maths will give you the answer. If it's a quadratic inequality, sketch-based answer. So now, over here, that's the whole thing. Now over here, let's look at this inequality. This is first you have to decide which case is this. Case 1 was modulus on the left lesser. Case 2 modulus on the left greater. Case 3 modulus on both sides. So this is both sides. When you square it, this 3 also gets squared because this is like squaring both sides. So 3 becomes square, x plus 2 becomes square. You get all these terms. You transfer them to one side. You make sure the coefficient of x square is positive. You do the middle term factorization and you are back to P1. So from this stage, this is back to P1. Lesser than 0, one single region, one single answer. That is the answer. Something like this thing, in some places I have used the sketch also, but I personally solve it using the algebraic method. It's a matter of preference. Anyone can solve it any which way. For example, 2x minus 1 modulus is less than 3 times x plus 1. So the same question, if someone wants to solve it this way, first they will solve the equation, they'll get the critical values. They have to draw a very realistic sketch, but unfortunately is not possible for many. So this blue one is the sketch, the modulus sketch. That is the blue one. And this green one is the modulus sketch of the right-hand side. And then these are the critical values. And then it says the blue is lesser than green. So blue is lesser than green. That means green is at the top, blue is at the bottom. So if we go to the right of the critical value, green is at the top, blue is at the bottom. Left of this value, left of this value, and now green is at the top, blue is at the bottom. But I personally prefer the other one. If they ask for a sketch, of course, we can draw it. Now, something like this. Sketch the graph of y is equals to 2x plus 1 modulus. Solve the inequality. This left side is greater than this thing modulus. Now, first of all, the way that I do it is that I'll transfer the modulus to the left-hand side. 2x plus 1 modulus is greater than 3x plus 5. That means 2x plus 1 is greater than 3x plus 5. 2x plus 1 is lesser than negative of 3x plus 5. Now it so happens, this is important, it so happened that both inequalities are moving in one direction. So now what we do is that, is the overlapping region is the answer? Is the union is the answer? Is this thing in between is the answer? We don't know. So we choose simple values. Let's say lesser than negative 4, let me choose negative 5. Between these two, let me choose negative 2. Both inequalities are moving in the same direction. Apply the true-false test. That is what I do. If I plug in negative 5 in the original inequality, it proves that this inequality is true for this particular value. Now, this particular value means this whole range, this green range. So yes, if this is true, then anything in this range will be true. If I plug in x is minus 2, a value in this region, it's also proving to be true. 3 is greater than minus 5. So not only is this region true, this region is also true. So basically this inequality, the red one, is the answer. Someone can say, what if this one would have been false and this is true? Then only this thing would have been the answer. X is lesser than minus 4. So that's how this thing is done. So that's about modulus inequality. Let's talk about partial fraction. I don't want to go much deeper into it. We will talk about it when we'll be doing the questions of integration. Binomial is light. Let's treat it that way. And let me just focus on polynomials over here. Now, polynomials is something very, very important. That is linear, quadratic, cubic, quartic. Quartic means a power 4 equation. So these are all polynomials where the powers are an integer, power 4 maximum. Remainder factor theorem, a cubic equation, solving, sketching, nature of roots, algebraic division. That was about linear divide by linear, quadratic divide by linear, and so on. Different kinds of things are there. So now people, let's focus on this. Now, first of all, the factor theorem, that is this basic idea. If a polynomial is divided by a linear factor, if I plug in this value in this equation, if it equals to 0, that means x minus a is a linear factor. Now, this also has implications in complex numbers. Okay, so not only it's for an algebraic thing, it's also related with algebra of complex numbers. For example, fx is this thing. If I plug in 3, it does not equal to 0. That means x minus 3 is not a linear factor. And this is the remainder theorem. So factor theorem, if it equals to 0, x minus a is a factor. This is the symbolic thing. A basic question related to this. The polynomial where a and b are constants is denoted by px. It is given that 2x plus 1 is a factor of px. So this is px. When px is divided by x plus 2, the remainder is negative 24 and 2x plus 1 is a factor. If 2x plus 1 is a factor, equate it to 0. This is the plug-in value. And of course, it's only applicable for a linear factor. So p of negative half, write it down, expand, simplify, take care of the basic maths, equal it to 0. So that's one equation. This is factor theorem. The next one, when it's divided by x plus 2, the remainder is negative 24. So x plus 2 equals to 0, plug in minus 2. So let me write over here. So x plus 2 equals to 0. Therefore, x is negative 2. In other words, p of negative 2 is negative 24. That is the second equation. That is giving me the second equation. The first equation is there. Solve it simultaneously. You find the value of a, you find the value of b. So this is the basic thing about polynomial. Then let's talk about long division. Algebraic division, the official name is algebraic division, but this is also in slang, we call it long division. So now let's have a good look over here. We have x squared minus 5x plus 6. We are dividing by x minus 2. So take the highest power x squared, take the highest power from here x. X squared over x is x. Now multiply x with this, now multiply x with this and write it down. Change the sign and add. So when I use the term change the sign and add, it means subtract. Got the idea? So change the sign and add, it means subtract. So we simplify, we get this thing, pull one more term down, repeat the same process. Negative 3x over x is x, sorry, negative 3x over x is negative 3. And then we get the same thing, the denominator, the remainder is 0. So if it's a factor, it's necessary that the remainder is 0. So x minus 2 into x minus 3, that is the polynomial. Something more. Have a good look. Have a good look for yourself. Okay, people, let's get started. So now we have this thing, which is x cubed divided by x. So x cubed over x, that is x squared. So there are two terms over here, x squared into x squared into minus 1. Repeat the same process, change the sign and add. So an x squared term is left. Since there are only two terms, just pull one of them down. Negative 5x squared over x is negative 5x. Multiply it out. Again, this cancels out. And we are left with 6x. Transfer this down. Repeat the same process. And then this cubic equation is this linear factor into this quadratic factor. So now that's how this thing is written. Now, if it's factorizable, so now we would factorize it. If it's not factorizable, so we would leave the answer as it is. So now this thing is done. If they say solve the equation fx equals to 0, then we would take the factors, we will equal it to 0. So this will give me 1, this will give me 2, this will give me 3. That's how the factors are obtained. Solving cubic equation. Find the first root by trial and error. That is called factor theorem. So you just plug in different values. Any value which gives me 0, x minus that value is the linear factor. And then we carry out long division, just like what you have seen, cubic divided by linear. We get a quadratic quotient, factorize, and you get the answers. Also remember this thing, very important. This thing dividend, that is divisor into quotient plus a remainder. What it means is that if this is x squared minus 5x plus 10, and if I divide it with x minus 2, and I get a 4, so how can I write it? How can I obtain this? So I take this thing, that is the divisor. This thing, the quotient, that's over here. When you multiply it out, if the remainder was 0, you would add a 0. If the remainder is not a 0, you would add a 4. So in this case, the 4 was the remainder. And these two multiplying together plus this thing gives you this. So remember this equation. Sometimes they ask you to write it out. Sometimes it's about solving a cubic inequality. It says the polynomial where a is a constant is denoted by px. It is given that 2x plus 1 is a factor. So 2x plus 1 equals to 0, x is negative half. Find the value of a. We plug in negative half, equal it to 0. Simplify, we find the value of a. When a has this value, factorize px, just like what I did, solve the inequality px greater than 0. So now over here, we plug in the value of a. The coefficient of x squared is missing. It's missing because the coefficient is 0. So make sure that you write in the proper order, the cubic, the quadratic, the linear, the constant. Divide by the same process. You get a 0 at the end, and you get this thing. Now double check whether it has any real roots or not. So the discriminant of this quadratic, again P1 is involved, is coming out to be negative. So there is only one real root. So coefficient of x cube is positive. We start with the top right, we go till the bottom left. This is the only route through which it's passing. So yes, the idea of sketch, that's the way I do it. Px greater than 0. That means the region of the graph above the x-axis. So you go right of this root, px is greater than 0. That's how you get this answer. So that is about polynomial. Let's talk a little bit about logs. So logs is very important. The rules of indices, yes, they are very basic, but its application, using it at the right place, that makes all the difference. Okay. So now over here, exponents, indices, power, if they have the same base, multiplication gives rise to addition of power. And division, that is about subtraction. So keep this thing in mind. The base are the same. Excuse me. Multiplication, the powers add up. Division, the powers subtract. What if the powers are the same, but the bases are different? So technically, we would take this power common out of the bracket and the bases multiply. A power m divided by b power m, different bases or same bases, that's not the issue. Power has to be the same. So now divide on the inside, power is on the outside. A raised to power of negative m, that is 1 over a raised to power of m. A over b raised to power of negative m, that's b over a raised to power of positive m. A raised to power of mn, the powers multiply. Root m, that is a raised to power of 1 over m. And let me write one other thing also. That is when we have to make something the subject. That was used in P1 a lot. A power m, if it equals to b, therefore, if I make a the subject, that is b raised to power of 1 over m, which makes common sense. If a square is equals to b, a is square root of b. If a cube is equals to b, a is cube root of b. So now just apply the same principle. Basically, this is about the reciprocal. 2 becomes half. 3 becomes 1/3. And this is also very, very important. Got the idea? Okay. So now the index to the log form, the heart and soul of pure maths. the conversion. It comes in differentiation, integration, differential equations a lot. So the index to the log form, y is equals to a power x, log y base a equals to x. 32 is 2 power 5. Therefore, log 32 base 2 is 5. 1 over 9 is 3 power negative 2. Log 1 over 9 base 3 is negative 2. Over here, the last two, just focus on them specially. So now over here, it says 1 is 5 power 0. So log 1 base 5 equals to 0. 4 is 4 power 1. Log 4 base 4 equals to 1. Now, these two things, they play a very important role. And there are some limitations. The first thing, there is also, if I talk about this thing, 1 is 10 power 0. Log 1 base 10 is equals to 0. Log to the base 10 is known as LG. 1 is e power 1. Log 1 base e is 0. Therefore, ln of 1 is 0. So now this rule is very, very important. Log 1 base a equals to 0. Two things are necessary. We only deal with a positive base, and in positive, 1 is not a good number as a base. So log 1 to any base, that was some correction that was done earlier. So log 1 to any base equals to 0. Log 1 to any base equals to 0, and any base, this is the limitation for any base. Base has to be positive, base cannot be equal to 1. The next one, log 10 base 10 is 1, Lg of 10 equals to 1, log e base e equals to 1, ln of e equals to 1, log of any number to the same base is 1. Again, the limitation is the same. A has to be positive. A should not equal to 1. Log to base 10 is log without any base, or Lg. Log to the base e, ln. This is common log. This is natural log. Again, very, very important rule. What are the important rule? The first one is this thing. Log 10, Lg of 10 equals to 1. Lg of 1 is 0. Similarly, over here, what is the important rule? That is ln of e equals to 1, ln of 1 equals to 0. Lg of 1 is 0, ln of 1 is 0, Lg of 10 is 1, ln of e is 1. So these four rules are very important. Then there are some other rules of logs. That is, if two or more than two terms are multiplying inside a bracket and there is a common log that we are taking, so this gives rise to addition. It is related with indices, but we don't have to waste time over that. Log x over y base a, this division becomes subtraction. This product becomes addition. So product rule. So now basically product becomes addition. And over here, this quotient becomes subtraction. Got the idea? And then there is this power rule. Log x power m base a, the power comes down and multiplies. That is called the power rule. Okay? So power comes down and multiplies. If there is a positive sign inside the bracket, if there is a negative sign inside the bracket, you cannot expand it. No such rules exist. Very important. For log y base a to be defined, a has to be positive, the base has to be positive, base should not equal to 1, and y should be greater than 0. Now, something like this. Read the question first. I'll just have a look at the comments section. Okay. Now, people, let me just go over this thing. Then I'll go to the examiner report and I'll talk about what you people are asking. Showing all necessary working, solve the equation 2 log x base 2 is equals to 3 plus log x plus 1 base 2. So now this is log base 2. This is log base 2. This is a number all alone. So now I have done this thing in two ways. The first method, first of all, raise this as the power. Take this term to the other side. So let's just focus on this. So this becomes log x square base 2 minus log x plus 1 base 2 negative. Now I'm compressing it. That is division. If I want to expand, that goes like this. If I want to compress, that goes like this. So now when we reach this stage, we apply the concept that we are taking log of this number. So log of this thing to the base 2 equals to 3. So log of this to the base 2 is equals to 3. Therefore, 2 raised to power of 3. Base raised to a power equals to this whole thing. Got the idea? That is the first thing. And then you get this quadratic equation that I'll talk about it soon. So method number 1 is using rules of logs and then changing it into the index form. That's the first one. So now let's talk about method number 2. We know that log of a to the base a is 1. Log of 2 to the base 2 is 1. If I multiply 3 into 1, that will remain as a 3. So can I write this thing as 3 log 2 base 2? Of course. Can I make this the power? So therefore, this is log 2 raised to power of 3, which is log 8. This 2 also becomes the power, that is log of x squared. Now I'm not transferring this to the other side. I have logs on both sides. Now this plus means multiplication. So this is 8. This is x plus 1. They multiply. Now this is log to the base 2. This is log to the base 2. If there are two terms like this, log m base a, if it equals to log n base a, in other words, m equals to n, and we get the same thing. Now have a good look over here. So they both are done on the same page. And they could have been done differently also. And then you solve this equation. And this is P3. So don't expect that everything will be factorized using middle term factorization. Quadratic formula has its own rule. So A is 1, B is -8, C is -8. That's the way I do it. I first evaluate B squared minus 4AC so that I am at peace that I know that b square minus 4ac is a positive value. Yes, I'll be getting solution, but it's not a number such that I'll be able to have a perfect square number. So this is not like that. So therefore, I apply the whole formula. The value of x is positive. The value of x is negative. And log of negative does not exist because x is such a number. That is why we are discarding it. Work in 4 significant figures. Final answer 3SF. X is 8.90. So that is the mark scheme over here. Okay, now let me focus the same kind of question. Another one like this. Have a good look. Show that this equation can be written as a quadratic in x. That means a quadratic equation in terms of x. Hence, solve the equation, giving your answer correct to 3 significant figures. So now over here, we have this equation. We are working in base 10. Again, there were two options. The first option, transfer to the other side, the method 1 that I just did. This option was there. Or the second option is this, log 2 base 2 is 1, log 10 base 10 is 1. So I'm using the second option over here. So now, since this is base 10, this is base 10, they won't be changing the base. That's not part of the syllabus. Keep that in mind. So now this is 2 log 10 base 10. This 2 becomes the power. That is 10 square. Minus signs means division. Log of something to the base 10, log of something else to the base 10. Therefore, this thing equals to this thing. Again, you get a quadratic equation, quadratic formula. Reject the negative answer, accept the positive answer. Why are we rejecting the negative answer? Because log of a negative number does not exist. Okay, something to do with natural log. It says ln x squared plus 4 is 2 ln x plus ln 4. Now, every single term has an ln in it. This 2 becomes the power of x. This addition becomes multiplication, ln. So therefore, x squared plus 4 is 4x squared. Make x squared the subject. So x is negative, x is positive, except this. And they are asking the answer in the exact form. So leave the answer in the exact third form. Let's move ahead. Something like this thing. Given that ln 1 plus e raised to power of 2y is x, express y in terms of x. So this time you don't have to solve it, you have to express it. Now look at the working. Ln of something equals to x. Therefore, 1 plus e raised to power of 2y, let me again highlight this thing. So now this thing, 1 plus e raised to power of 2y, that thing is equals to this base raised to power of x raised to power of x. That is the first thing. And then what we do is that we have to make y the subject. Now, in order to make y the subject, I need to take this y down. So what I did is that I wrote e raised to power of 2y on the left hand side, 1 is taken on the right hand side, then take natural log of both sides. So ln of e raised to power of 2y, ln of ex minus 1 cannot expand the bracket. So just a caution, cannot expand the bracket. Okay, so that's the thing. So now this 2y comes down, ln e, this is ln of this much, make y the subject, that is the answer. So basically from log form to index form, that's the first thing. And then again, by making e raised to power of 2y the subject, again we are taking ln of both sides. Now, this is something related to this exam report and something. So let me just go over here. 1, 2, and 3, that is mechanics. This is for June 2025. And let me focus on the exam report. So now my focus is on exam report. And I'll be reading 1 or 2 exam reports. Let's say 1 from June, 1 from November. So this is June 2025. This is May, June 2025, variant 31. And then I'll be looking at some other ones also. Now, very few things are written over here. In the exam, give your full attention to the question asked. I think the examiner wants to sound a little bit sarcastic. Practice the basic methods so that you recognize the standard patterns. Yes. Now, someone was asking this question. That is, how many past papers are necessary? Now, first of all, today is Tuesday. So now we are left with Wednesday and Thursday. So it's like around 60 hours are left. So what you need to do is that at least try May, June 2025 papers, October, November 2025 papers. There are 4 variants. 31, 32, 33, 35. The same thing goes over here. If you can try out these 8, that would be perfect. And if you're able to try out a little bit more, even more perfect, but at least these 8 for now, from the perspective of now, would suffice, because these are very nice questions. And I selected all complex numbers question from out of all of these, even February, March 2025. And then I made 4 different videos. So those 4 different videos, they were about square roots. They were about the trigonometric form. They were about the loci. They were about the algebra. Do check them out, because some of the questions, the concepts were asked in a different style. So very, very important. Similarly, I will be making maybe 1 or 2 more videos, one on differentiation, integration, one on vectors, something like that. So that will be coming in a day or 2. So now that all depends on how many papers have you tried. So first try them out. Yes, there would be one or two paper that has a very low threshold. Do not be demotivated by that, because that is like people are appearing less and the paper of course was difficult, but just try out at least these 8 if possible, also the ninth one. Now it says this thing, develop problem solving skills so that you are aware of the methods relevant to the given situation. That means every single thing. Like over here, I just talked about the modulus thing, the polynomial thing, and all of these. So you know exactly what you need to achieve. Set your work out clearly so that the examiner can follow what you are trying to do. So now this examiner over here, or a group of examiners, they are very, very particular. They are very precise in what they are writing. So they are writing in a precise manner. They want clear, logical, working. They want you to be aware of the normal questions, and they want you to read questions carefully. And you should read at the beginning, of course, before starting the question, and also at the end, so that you know exactly what they're asking. Now, let me go to the next one over here, thumbnail. So this one is there. That is the next one. Okay, over here, let me highlight some more important things. Read the question carefully. Make sure that you have found what you were asked to find. That is, read the question at the end. In this paper, this is variant 32, May June. In this paper, many candidates lost 2 marks because they found the term in x square, but not the expansion up to and including the term in x square. So that is a very good thing that they have done by emphasizing on this. When a question requests a particular method, then marks are not available for an alternative method. This was particularly relevant in question 5, which requested the forming of a quartic equation, and question number 9, which asked for the use of a scalar product of vectors. Then, if a question starts hence, then this question requires you to use the outcome of a previous part. In 7b, marks were available for the correct use of an incorrect answer from 7a. Now that is very important. Read it once again. Marks were available for the correct use of an incorrect answer from 7a. A lot of people, they ask this question about follow through. Yes, your part A might be wrong, but if you use this part in the correct manner, based upon hints, marks will be given. And when will marks be not given? But not for a fresh start using a completely different method. Similarly, in question 9c, marks were available for the correct use of an incorrect answer, but only if this was based using the angle BAC. So some scalar product thing. Then it says, write clearly, ensure that the numerals are clearly distinguishable from one another. In some instances, candidates misread their own writing. So 1, 7 are numbers like this, people mix up. Do not mix them up. When a formula is given on the formula booklet, no credit will be earned if the formula is misquoted. Okay, so that is, read this again. So now if the formula is misquoted, there is 0 credit. This applies particularly to using correct trigonometric formulae and correct methods for differentiation and integration. So that's the main thing. So now this is the basic idea. Let me go over here. That is in logs. And yes, the second most important thing that people ask is this. If you have non-exact answers, you need to round off. Angle and degrees work in 2 dp, final answer 1 dp. Anything else work in at least 4 significant figures. So the word is at least. And if you work in 4, that's perfect. Final answer 3SF. Unless otherwise stated, that means in a particular question, if they're asking, give the answer as an integer, so you would listen to the examiner. You would give the answer as an integer. Now, exact forms. In P3, there are 5 exact forms that you deal with. The first 3 were also in P1, but in P3, there are 5. Which ones are those? Read it for yourself. Let me drink some water. So now over here, we have the fraction form, we have the surd form, we have in terms of pi, the exponential and the ln, and exact answers need no rounding off. If I'm getting an answer as 0.3, so I'll simply write it as 0.3 because that is exact. Okay. Yes, something like this. Let's go over this. Showing all necessary working, solve the equation 5 raised to power of 2x. So this is 5 raised to power of 2x is 5 raised to power of x plus 5. So make a substitution. Let m is equals to 5 raised to power of x. And 5 raised to power of 2x can be written in 3 different ways. Just have a good look. The 3 different ways are 5 raised to power of 2 raised to power of x. 5 raised to power of x raised to power of 2. 5 raised to power of 2x can also be written as in green, 5 raised to power of x into 5 raised to power of x. So you can either choose the green one or you can choose the extreme right one. So 5 raised to power of x raised to power of 2 is m squared. So this is a disguised quadratic equation, as you have seen in P1. Now, again, this is P3. So it is a little bit stubborn. And what happens is that the b square minus 4ac is coming out to be 21. That means you cannot take the square root of a 21 in terms of fractions or integers. So therefore, what we do is that we use the quadratic formula. We can quote the quadratic formula, but quoting won't earn us our marks. We have to show all the working. So minus b plus minus b square minus 4ac, this whole thing divided by 2 times a. One of the value of m is negative. Since m is 5 power x, you cannot take square root, you cannot take log of a negative number. And over here, look at the working. I get this m value, 1, 2, 3, 4, 5, 6, 6 significant figures, not bad, no issue. 4 SF is the minimum. 5 power x is this much. Take log of both sides, any log would do. LG, ln doesn't make a difference. And then you get this final answer. So that is something like this. Let me look at this. This kind of question also comes. Showing all necessary working, solve the equation. E power x plus e power negative x, e power x plus 1 is 4. So now over here, what I did is that, first of all, e power x plus e power negative x is 1 over ex. So let me just highlight this. E power negative x, that is 1 over ex. And then I simplify like this. And then this is e power x into e power x, that's e power 2x. I have written it deliberately like this. I have made the substitution, then I made it into a quadratic equation. Let me see if there are questions on linear law. Yes, there it is. Linearization, linear law, it's a combination of quadratics and logs. Sometimes they give you to draw a question, draw a graph yourself. 2 variable quantities, x and y, are believed to satisfy an equation in the form such and such, where c and a are constants. An experiment produced 4 pairs of values of x and y. The table below gives the corresponding values of x and ln y. So this is x, this is ln y. Now they use ln, they hardly use LG in linearization. As such, there is no issue, but I'm just talking about a trend. So now look over here, that is the first part. Y is equals to c into a raised to power of x. Now look at the working yourself. What have they done? They are taking natural log of both sides. So y becomes ln y. And on the right hand side, there is c and a power x. So C and A power x are multiplying. So when you open it up with ln, you get a positive sign. Then x will come out and come down and multiply. Then you have to compare coefficient with y is equals to mx plus c. Have a good look. Ln y, that is like your y-axis. And ln c, a constant all alone, that is the y-intercept. And then x into ln a is like x into m. So m is ln a, x has to be the variable. Now when we are drawing it, have a good look. What is on the y-axis? That is ln a. What is on the x-axis? That is x. And then you plot the points. And step 2, plot, draw, calculate, read. So now step 2 is plot. And step 3 is that you have to, after plotting, first of all, it's not necessary that all 5 values will lie on the straight line. That is why in O-level maths, you have read the scatter diagram concept. So this is like a scatter diagram. Okay. Draw the line to the best of your ability where it touches the y-axis, that's the y-intercept. Choose any 2 nice points, whichever one are easy to read, find the gradient. So find the gradient, find the y-intercept. Now we are on step number 3. That is this thing, ln of a equals to m. So red one, so this is ln of a equals to m. And then the blue one, capital C is equals to ln of c. Capital C equals to ln of c. So now capital C is the C from the graph. That is 1.3. So therefore, C is e raised to power of 1.3. Write the value. Ln A equals to m. A is e raised to power of m. This is m.4167. And that's how you get the value of A. So you find A, you find this thing, and these are the corrected answers. So I think that is all about logs. Trigonometry, I'm not, yes, it's there. But let me think about it. Trigonometry, I'm not focusing on it right now. Let me first start with differentiation. So let me focus on differentiation first. That is over here. And let me also open it up, integration. And then where is that? Differential equations. That is over here. So now, first of all, this is integration. This is differentiation. Let me first start with differentiation. So trigonometry, we can do it later also, like tomorrow or something. So right now, I want to focus on differentiation, integration, differential equations. Of course, bits and pieces of trigonometry would still be there. So now, differentiation, rate of change of y with respect to x. That is how you got started in P1. The basic rules of P1, the basic differentiation, the basic chain rule. Don't forget to multiply by derivative of bracket. People forget that, and that causes a lot of problem. So now this thing, exponential. Y equals to e raised to power of ax plus b. So what happens is that we have this thing, which is this exponential remains as it is. It does not change. And the derivative of the power comes down and multiplies. There is no limitation on the power. Fx, f prime x, the derivative of ex is ex, e2x is 2e2x, e raised to power of negative 3x, negative 3 e raised to power of negative 3x, and so on. Ln, log function, natural log. Y is equals to ln ax plus b. So whatever is inside the bracket, that goes down in the denominator, derivative of the bracket goes up. Now, all these things, they are used in integration also. Ln disappears. And ln appears when we are doing integration. Ln of x, x goes down, 1 goes up. Ln 2x, 2x goes down, 2 goes up. Yes, it simplifies to this thing. Ln of 1 plus 3x, 1 plus 3x goes down, 3 goes up. Ln of 2 minus 5x, so 2 minus 5x goes down, negative 5 goes up. ln of x square goes down, 2x goes up, that is 2 over x. Something to do with the trig function. So y is equals to sine x. The derivative is cos x. Now, people, a word of caution. That is, you are doing differentiation, you are doing integration. So the formula booklet is there for you to have a look. Yes, you should remember it, but if you are in doubt, check it out. So sine x, derivative of sine is positive cos. Y is equals to cos x, derivative is negative sine. Derivative of tangent is sec square. And yes, in a very recent paper, which I was solving earlier for your videos like this one. So yes, this also happens that in one of the question, we are interested in the first three, but this time they are also asking to, they are also starting to ask this kind of question. Derivative of sec x, that is sec x tangent x. So now this I'm talking about this particular paper, which is October-November 2025, variant 33. So this thing is used. Okay, so you can check out that question later in the video that's in the process. So now over here, sine 2x, that becomes cos 2x, 2 comes down, 2 comes out and multiply. Derivative of the bracket comes out and multiplies. So differentiation, the rule is multiplication. And then have a good look at the other ones. Cosine of 3x, that is what? That is negative 3 sine 3x. Actually, cosine 3x is negative sine 3x, 3 comes out and multiplies. Tangent of 4x, that is 4 sec square 4x. Sine bracket 2x plus pi by 3. Sine will become cos, 2 will come out and multiply. Nothing will happen to the things inside the bracket, they won't change. Cos becoming negative sine. And there is also the negative of the bracket. This negative is the coefficient of x. This negative is because of cos and sine differentiation. Tangent, that is sec square, 3 comes out and multiplies. A combination of exponential and trig. Very common question. U is e power x, u prime is e power x, v is sine 2x, v prime is 2 cos 2x. This multiplies with this multiplies with this. And in exponential, you always have the freedom of taking common, which you should use. So taking common is a must. Something like this, y is equals to x square ln x. Now, whether they write it or not, whenever something with ln will appear, it's necessary whatever is over here, that should be positive. Why? Because log only exists for a positive value. So this is x squared, this is 2x, this is ln x, this is 1 over x, this is product rule. I'm interested in coordinates of stationary point. X squared into 1 over x, 2x into ln x. I can take x common out, 1 plus 2 ln x. Let me do the differentiation once more. And this time I'm interested in product rule once again because I need the second derivative. U is x, u prime is 1, v is 1 plus 2 ln x, v prime is 0 plus 2 into 1 over x. Again, u, v prime, v, u prime. So now this simplifies to 3 plus 2 ln x. First step, that is derivative is this thing equal it to 0. X equals to 0, 1 plus 2 ln x equals to 0. 2 ln x is negative 1, ln x is negative half, x is e raised to power of negative half. Why is it rejected? Because ln does not exist for negative values or 0. Ln only exists for positive values. The second thing, this is the only x coordinate. Now plug in x coordinate of turning point in equation of curve. Now plug in x coordinate of turning point in what you call, that is the second derivative. So now over here, this is equation of curve to find what y coordinate of turning point. Now plug in x coordinate of turning point in second derivative to find nature of that particular thing, of the turning point. So now over here, let's focus on this. x square ln of x, e raised to power of negative half raised to power of 2. The powers multiply, e raised to power of negative 1, which can be written as 1 over e. Ln e raised to power of negative half, that is negative half ln e is 1. So this is negative half, this is 1 over e, so this is negative 1 over 2e. So leave the answer in the exact form. Now over here, we are plugging in the second derivative. This is 3 plus 2 ln e raised to power of negative half. This is 3 plus 2 into negative half ln e. Ln e is 1. 3 into 2 and 2 cancels out. 3 minus 1, that is 2. That is positive. It's a minimum. Now, the next thing that I want to focus on is this thing. And let me write few things over here. That is this thing, which is when we talked about the examiner report, we talked about the important things that the examiners are asking. We talked about algebra. We talked about logs. We skipped trigonometry. Now we are on differentiation. Now, whenever a question of trigonometry comes, if it's related with circular measure, if it's related with numerical solution, if it's related with differentiation, whether it's related with integration, word problem of integration is called differential equation, and maybe a trig equation or a trig sketch or a trig something, conceptual question. So over here, this is the only place where they might ask in degrees. Rest of the thing, it's about radians. So rest of the thing, that is about radians. And yes, if I include vectors and you are using scalar product, so both are acceptable. Degrees are also good. Radians are also good. That is both. But over here in these ones, radians is compulsory. It's compulsory in circular measure, numerical solution, differentiation, integration, differential equations. It's compulsory in trigonometry. It could be about a radians or a degrees. In vectors, it could be radians or degrees. So that's how this working thing is important. Coming back to this. Now over here, it says the curve with the equation has one stationary point in the interval. Find the x coordinate of this point. Give your answer correct to 3 significant figures. Now, this is the range. Of course, in trigonometry, that range always has to be given. So now this is sine x into cos 2x. Now, first of all, when you are differentiating it, don't worry about the double angle thing. This is single angle, this is double angle. Derivative of sine is positive cos. Derivative of cos is negative. This 2 comes out and multiplies. So first thing is product rule. Next thing, this is u, this is v prime, this is v, this is u prime. Then we have sine x into this thing, cos x into this thing. Now I'm writing sine 2x is 2 sine x cos x according to double angle. So here the trigonometry part automatically comes in. And cos 2x, I can write in terms of cos, I can write in terms of sine. Now I have made a decision that is this sine into this sine would be sine square. So that is the reason I chose this one. So now let me multiply it out. And before multiplying, I have this liberty of taking common. So I took cosine x common. I'm left with negative 4 sine square x, negative 2 sine square x plus 1. And this is what I get. Dy by dx equals to 0. What are they asking? They are asking has one stationary point in this interval. Now, we think that there might be two answers. So if I say cos x equals to 0, Let me draw the portion of the graph. The whole graph is like this. I'm just drawing from 0 till pi by 2. Neither is this inclusive nor is this inclusive. Otherwise, if it was inclusive, pi by 2 could have been the answer. But because of the range, we are rejecting it. So also state the thing that why are you rejecting something? So now that needs to be stated. So let me remove this one for right now. So explain why a certain value is rejected. For example, if I have the scenario, m square is -2, so we rejected y can't take square root of a negative number. Even in complex number, when we are talking about square roots, complex number, we talk about square roots, and the square root is in the form x plus iy. So what is the condition that they put in? The condition that they put in is that x and y are real. So again, this thing is applicable over there. What about something like ln x plus 1? Something like this. X square ln x plus 1, something like this. And over here, whether they have given it or not, x plus 1 should be greater than 0. Therefore, x is greater than -1. So this inbuilt condition comes in. Sometimes this range comes in. This is 0 and pi by 2. So therefore, x is coming out to be pi by 2 in one thing, cos x is equals to 0. X is pi by 2, but we are rejecting it. Why are we rejecting it? Because of this range. It's not inclusive. And things like that. Sometimes a graph will be given. So the graph will be giving me the range. Sometimes it could be about log of something base A. So this something has to be positive. So this something inside the bracket that has to be positive. The same thing that I applied over here. It's the same application over here. So these are some of the reasons why we reject a particular answer. So state the obvious. Now over here, we have -6 sine square x plus 1 equals to 0. 6 sine square x is equals to 1. Sine square x is 1 over 6. Sine x is plus minus 1 over root 6. Answer is all 4 quadrants, but we are restricted by this range. So technically, we are just calculating the basic angle. Work in at least 4 SF. This is x is this much. The first quadrant, x is the same thing as the basic angle alpha. X is 0.421, rounded off to 3 significant figures. Now this thing is done. Something like this. Find the exact coordinates of the point on the curve at which the gradient of the tangent is equal to 1/4. So we know that gradient of tangent, that is dy by dx. Normal is the negative reciprocal. So now this is an application of quotient rule, and they are asking the exact coordinates. Coordinates means both x and y. The quotient rule is u over v. The u is the numerator, v is the denominator. We start with v, that is v u prime minus u v prime divided by v square. Look at the working. U is x, u prime is 1. V is 1 plus ln x, v prime is 1 over x. So now 1 plus ln x into 1, that is x into 1 over x, divided by v square. First, simplify the numerator. I have a habit of writing this thing on the sidelines. I don't want no mess-ups. Equate it to 1/4. You have this disguised quadratic equation in terms of ln. So let m is equals to ln x. M square is ln x whole thing square. You solve. You get the value of m is equals to 1. Ln x is 1. X is e raised to power of 1. Y is x over 1 plus ln x. E plus e divided by 1 plus ln e. That is this answer. And that is the exact coordinate. Okay. Let me choose. Yeah, this one was a very nice question. Just have a good look. First, read it. Now it says the curve y is equals to sine bracket x plus pi by 3 cos x has two stationary points in this interval. Find dy by dx. And then the special thing is this one. That is, by considering the formula for cosine bracket a plus b, show that at the stationary point on the curve, this thing is equals to 0. Now, if I write the formula of cosine a plus b, let me write it so that you can have idea what I'm talking about. So cosine a plus b, that is cosine a, cosine b minus sine a, sine b. So remember, if I expand it this way, this is expansion. And if I go the other way, this is compression, opposite of expansion. That means if something is written like this, there are two terms with cos, there are two terms with sine, there is a negative sign in the middle. This is A, so A goes in the bracket, this is B, B goes in the bracket, negative sign is giving me positive. So compress it. That's what the examiner is giving you the hint by considering the formula. Now, first of all, this is product rule, sine x plus pi by 3. That is cos x plus pi by 3, coefficient of x is 1. Even if it's as obvious as this, make a habit of writing it. Derivative of cosine is negative sign. U into v prime, v into u prime. You multiply it out and don't open it up. Just stop. It so happens that the two sine terms with the negative sign are written first. The two cos terms with the positive signs are written later. So technically, this is cos x, cos of the bracket, minus sine x, sine of the bracket. Got the idea? So this x is like your A. This bracket is like your B. This x is like your A. This thing is like your B. There is a negative sign in the middle. So therefore, cos A cos B minus sine A sine B. Therefore, this thing simplifies to this. Now, x plus x is 2x. And it's not quite easily done. Very sharpness of mind was needed. They have given very few marks because it was tricky. Hence, find the exact coordinates of the stationary point. So exact coordinates, cos 2x plus pi by 3 equals to 0. Now we know that cos of 90 degrees, basically this thing over here, some people might feel that suddenly how come this thing has appeared? So this has not appeared suddenly. That is the basic idea of cos. That is, if I draw the grid and that is like half of the curve, and this is like this, hold for a second. And let me draw this portion like this. Okay, so now over here, if I mark it, this is 2 pi, this is 0, this is pi, this is pi by 2, this is 3 pi by 2. Now have a good look. This is the graph of y is equals to cos x. Let me push this thing up a bit. So this is the graph of y is equals to cos x. Where is cos 0? So cos is 0 at pi by 2, cos is 0 at 3 pi by 2. So this equate it to pi by 2, equate it to this thing. You get one value, you get the other value. That is the answer. Now let's talk about parametric, implicit or parametric first. So yes, this is also very important. Now once I'm done with parametric and implicit, then we will take a 15-minute break and then we will continue with integration and differential equations. So now the parametric equation of a curve is this thing. X is equals to t plus cos t. Y is equals to ln 1 plus sine t. Now it's application of chain rule. Differentiate y, we get dy by dt. Differentiate x, we get dx by dt. It's in terms of t, that is why dy by dt. If it's in terms of theta, it will be dy by d theta. So now dy by dx, that is equals to dy by dt. So let me write over here that is dy by dt divided by dx by dt. So that is the application of this. That is dy by dx. Okay. So now this is, let me just highlight this thing. Okay, not this thing. This is dy, color has to be changed. This is dy by dt. This one is dx by dt, like this. And they are saying, show that dy by dx is sec t. And there is also a range given, which is for part 3, part 2. So now when we divide, this is cos t at the top, 1 plus sine t, 1 minus sine t. This is 1 minus sine square t. That is cos square t. So cos over cos square, 1 over cos, 1 over cos is sec. These identities are very important. Sine square, 1 minus cos square, 1 minus sine square. That is the first part. Now over here, hence find the x coordinate of the points on the curve at which the gradient equals to 3. So gradient is dy by dx. dy by dx. Give your answer correct to 3 significant figures. Have a good look. Let me minimize it and have a good look. Think for yourself. So now over here, sec equals to 3. That means cos is the reciprocal of sec. So no need to write sec as 1 over cos, then equals to 3, then make it the subject. Just reciprocate the other side. Sec becomes cos and 3 becomes 1/3. Cos is positive in first and fourth quadrant. Now this is from positive 90 to negative 90. Actually, negative 90 to positive 90. So this is in like fourth and first quadrant, except in the first quadrant, this is like 0 till 90. So go anti-clockwise. And 0 till negative 90, go clockwise. Clockwise angles are negative, anti-clockwise angles are positive. So the basic angle that is coming out to be this thing. I'm working in 4SF. One answer is this thing negative. The second answer is this thing positive. That is the t value. Okay, keep this in mind. This is t. What are they asking? X coordinates. So the examiner already told you, read the question again. Otherwise, I would have left the answer over here. Calculate in radian mode naturally. So t plus cos of t. T is this much. Plug it in. You get this answer. Now cos of t, I use this value. Instead of plugging this thing in and then evaluating it, let me just use the cos t value. That is how we got started in the question. And similarly, the other value based upon this, again, this is the same, but this t value is different. So cos of t is the same in both. And we are getting this answer, and that is the final answer. Another question of parametric. X is equals to ln this thing, ln of cos theta. And this is y is this much. So I'm writing y on the left-hand side so that I know that this goes in the numerator. Small tricks that saves the day. 3 theta becomes theta. Tangent theta becomes 6 square theta. Negative remains as it is. Ln of cos theta goes down. Derivative of cos is negative sign. It goes up. Application of chain rule. So now this is dx by d theta. That is this thing. This is dy by d theta. That is this thing. Now when we divide, look at the working. 3 minus 6 square, 3 minus 1 over cos square, LCM. This is division by negative sine over cos, multiplication by negative cos over sine. Things cancels out. We are left with this and so on. And that's the answer. Was this answer given? No. Express dy by dx in terms of tan theta. Now, our gradient of tangent is -1. So therefore, the gradient of normal is +1. Normal is +1. So we are going this way. So gradient of normal is +1. That is what's given over here. We need to find gradient of tangent y because dy by dx is gradient of tangent. So now take dy by dx and equal it to this. So now I have done it in another way also. Let's skip that for right now. So now over here, dy by dx is -1. That is gradient of tangent. You solve, you make the subject, middle term factorization was there. Final answer. Since the range is between 0 and pi by 2, that is why we are rejecting this answer. So every rejection has a cause. Tangent is +1, first and third quadrant. It's only applicable for the first quadrant. And then the x coordinate and then the y coordinate, they're only asking for the y coordinate. Let's move on. And let's talk about implicit over here. It says the equation of a curve is this. Show that dy by dx is this. In implicit, you cannot make y the subject of the equation. So if y is completely in terms of x, dy by dx is in terms of x only. Of course, the constants are there. If you cannot make y the subject of the equation, then dy by dx is in terms of x and y only. We differentiate both sides with respect to x. Whenever we differentiate x, no issue. Whenever we differentiate y, we have to write dy by dx, and in the end, make dy by dx the subject. So derivative of x cubed, that is 3x squared. Derivative of 3x squared y, that is product rule. 3x squared into derivative of y, 1 into dy by dx. Y derivative of 3x squared, that is 6x. And this thing, this dot over here, that is also applicable over here. Derivative of y cubed, that is 3y squared dy by dx. Derivative of a constant doesn't make a difference. This was in terms of x or in terms of y. Any which way, the derivative is 0. Make dy by dx the subject of the equation. So I'm making dy by dx the subject of the equation. All the terms with dy by dx on one side. So all the terms with dy by dx on one side, this has dy by dx, this has dy by dx, dy by dx is common. That is 3y squared minus 3x squared. 3y squared minus 3x. And then all the terms without dy by dx, take it to the other side. So negative 6xy becomes positive 6xy. This positive becomes this negative. And then make dy by dx the subject. Now it says find the coordinates of the points. There is more than one point on the curve at which tangent is parallel to x-axis. So when tangent is parallel to x-axis, numerator over denominator is 0. In other words, numerator is 0. When numerator is 0, this is what you're getting. X into x minus 2y is equals to 0. Therefore, x is 0. Therefore, x is 2y. Now solve it simultaneously with the equation of the curve. So now solve simultaneously with equation of curve. So now first plug in this x is equals to 0. So you get y is equals to cube root of 3. Then plug in x is equals to 2y. So when you plug in x is equals to 2y, this is x cubed, 2y cubed. So let me just focus over here. X is 2y, that is 2y, that goes over here. And then x squared, that is 2y whole square, that goes over here. The other terms were already in y. And we get a beautiful answer. Cube root of a negative number is negative. So x is 2y, that is also negative. So this is one coordinate, this is the other coordinate. Something exact coordinates of the point on the curve at which tangent is parallel to y-axis. A lot of people, they ask this question. Let's also look at the first part. Y e2x. So y e2x, this is y. Derivative of e2x is 2e2x. This is e2x. Derivative of y is 1 dy by dx. Similarly, minus as it is. Y square as it is, ex derivative is ex. And then ex as it is, derivative of y square is 2y dy by dx, derivative of a constant is 0. All the terms with dy by dx, take it on the left-hand side. All the terms without the dy by dx, take it on the right-hand side. And then we divide. The minus sign also cancels out. You need to give it exactly in the form that the examiner has asked, even if it means taking the negative sign common and then canceling it out. Important implicit parametric stationary type, dy by dx is numerator over denominator. Gradient of tangent is dy by dx. Tangent parallel to x-axis. Numerator over denominator is 0, therefore numerator is 0. Tangent parallel to y-axis. Numerator over denominator is undefined, therefore denominator is 0. In this question, they were asking tangent parallel to y-axis, denominator is 0, that's the denominator. 2y minus e power x is equals to 0, e power x is 2y. That is the equation. So this thing, e power x is 2y. So e power 2x, I'm writing e power x raised to power of 2, I'm replacing it with 2y. E power x, I'm replacing it with 2y. I get y is equals to 1. I get x is equals to ln 2. That is this thing. And also read the question. Coordinates, that means x and y. Of the point, only one point. So I think let's stop over here for the first break. And what time is it? So now we started at this time. And now this is 9:16. Let's meet at 9:30 p.m. This is a break. And then, inshallah, we will continue with the other topics. That is 9:30 p.m. onwards. We will focus on integration. We will focus on differential equation. So let's meet after the break, 9:30, 9:32. Let's take a good break and then get refreshed and come back. So, Assalamu alaikum everyone. Let's get started again. So now people are asking this question about which chapters are we doing today, which chapters are we doing tomorrow. That was stated in the beginning of the class, but some people they join in late. So in day one, that is today, 12th. And let me just double check that the voice is all good and everything is set. Yes, the voice is good. And okay. So now in day one, which is 12th of May 2026. We talked about algebra. Yes, I skipped binomial. We talked about logs. We talked about differentiation. I skipped trigonometry. I mean, a little bit is there already in differentiation. Now let me focus on integration. Let me focus on differential equations. So that is the first thing. That is for today. And for tomorrow, that is day two, inshallah. That would be 13th of May. Today is Tuesday. Tomorrow is Wednesday. So 13th of May, we'll be focusing on first thing will be complex numbers. Next thing will be vectors. Third thing I'll focus on that is trigonometry. And fourth thing, that would be numerical solution of equations. So these are the four things for tomorrow. So right now, where are we standing? We are done with this. Let me make it thinner. So we are done with this. We are done with this. We are done with this. And now we are starting after the break these two things. So this is one and this is two, and that is our focus over here. So approximately, if I'm not mistaken, so these two would take around like 90 minutes for me to do this thing overview. So now differentiation, let me remove it. Integration, let's start from the very, very basic. That is integration, and then differential equation. That also we'll be starting from the basic. So the whole purpose is make you understand the concept very thoroughly. And in integration now, it's the opposite. So integration, first thing first, have a good look. That is this thing, that when we integrate something, we increase the power by 1. Basic integration of P1. We increase the power by 1. We divide by the new power. If there is a constant multiplying, that remains on the outside, plus a constant of integration C. So n could be any power, but n should not equal to -1. The chain of rule of integration, this is only applicable for a linear expression. This rule is already there. So now the thing over here is this. Ax plus b raised to power of n plus 1, power n becomes n plus 1, divide by n plus 1, divide by the derivative of bracket or coefficient of x. It is the same thing because it's a linear expression, only valid for linear expression. Something from P1 that carries on to P3, actually more into P3, that is this thing. That if I integrate between the limits a and b, and if I want to put a negative sign, the limits will change its places. Or think about it this way. If this thing is given, this will be changed to this. So remove the negative sign, make it positive, the limits will change its position. Very important. The beginning of P3, that is 1 over ax plus b dx. So there are different formats which will give us ln. Remember the ln that disappeared, now it has appeared. If there is a linear expression in the bracket and it has a power of 1, that means the basic chain rule is not applicable. So now this will become ln 1 over a, where a is the coefficient of x, ln ax plus b, because the derivative of this thing is this. It's a simple rule. So now that's the first one. The next one, Now it says, if the numerator is the derivative of denominator, if there is a fraction, naturally, numerator is derivative of denominator. This is ln of denominator plus a constant of integration c. Now, I would like you people, those who are watching, to jot this down on the sidelines so that when I'll do some questions, you are comfortable and you know exactly what we are doing. Of course, you have studied it, but it's a good idea for revision also. So now, once this is done, let's move ahead. And let me just readjust things on my side. Okay. Now, rule number 1 and rule number 2 worked examples. 1 over x plus 1. Coefficient of x is 1. Even if it's as obvious as 1, make a habit of writing it. So this is 1 over 1. And this is ln x plus 1. This is again 1 over 1 ln x. 1 over 2 is taken on the outside. So again, it's 1 over 1 ln x. So just remove this 2 on the outside. And then this question is exactly the same as this. 1 over 1 minus 4x. So technically, this is minus 1 over negative 4 ln 1 minus 4x. Worked example 2. The numerator is derivative of denominator. So is 2x the derivative of x squared plus 1? Yes. So that is ln x squared plus 1. What if this 2 was missing? You needed a 2, so you write the 2 yourself, balance it out with a half, because multiplication by 2, division by 2 is technically multiplication by 1. So this thing on the inside, that is ln x squared plus 1, half remains on the outside. Similarly, 3x squared over x cubed plus 5 is the numerator derivative of denominator? Yes. So this is ln of denominator. What if the 3 was missing? So you write a 3 on the inside. In order to balance it, write 1/3 on the outside. This is part of the syllabus since 2020, important one. If you have a fraction in this form, 1 is a constant at the top. Any other constant, put it on the outside. Coefficient of x squared is 1. And there is a plus sign, not a negative sign. If there is a negative sign, that can become a partial fraction. That will become partial fraction. So this is x squared. This thing is a squared. So this is 1 over a tan inverse x over a plus c. And over here, there was might be one thing in differentiation that was skipped. That was differentiation of tan inverse. We will look at it later in one of the questions. So now 1 over x squared plus 1. This is 1 over x squared plus 1 squared. So a is 1. This is 1 over a. So this is 1 over a tan inverse x over a plus c. Something like 1 over x squared plus 4. That is x squared plus 2 squared. So now a is 2. This is 1 over 2 tan inverse x over 2 plus c. Over here, more adjustment is needed. This is 4x squared plus 9. This plus sign has to be there. Okay, this plus sign has to be there. So now 4, if I take common, this is x squared plus 9 over 4. This is 4x squared plus 3 over 2 whole square. So this division by 4, this was technically 1 over, if I want to write one more step, this is actually 1 over 4x squared plus 3 over 2 whole square like this. So what I did is that I took this 1, I took this 4 and write it as 1/4. So that I'm not distracted by the denominator. Now integration, when we talk about integration, these are the important details. So now over here, let me focus on integration. For that matter, differentiation. So now simplify things. whether it's about plus and negative sign, whether it's about fractions, whether it's about surds, whether it's about taking common. So whatever simplification kind of thing is needed, first simplify things. And as the examiner talked about it, uh, write clearly, because you have to follow through your working. So you have to follow through your working. That is necessary. That is something that needs to be done. So now that was part of simplification. Now over here, this is 1/4 as it is, 1/4 as it is. And this thing is 1/3/2, tan inverse x over 3/2 plus c. And let me write this 1/4 over here. So this is 1/4 over here. That 1/4 remains as it is. That 1/4 remains as it is. This 1/4 remains as it is because I was laser sharp focused on the denominator. So don't forget the numerator. Now, basically, type 1 kind of questions, the P1 techniques, partial fraction, and all this thing, whether it gives you ln, whether this gives you ln, whether this gives you tan inverse. So now over here, partial fractions come in from algebra. We talked about modulus, we talked about polynomial, and something like this. So this is an x cube at the top, this is x cube at the bottom. It's an improper algebraic fraction. That is the first thing that you need to see in partial fractions, whether it's proper or it's improper. If it's improper, then it's necessary that you should first make it a proper algebraic fraction, and that is what they're hinting at. This constant a over here, that is the quotient of long division. And this thing is the breakup of that partial fraction. So first thing first, you multiply x with x squared plus 2, which is x cubed plus 2x. That is the divisor. There is an x cube, x squared is missing. There is an x, there is this thing. So now over here, what we do is that write that x squared with a 0 coefficient, write this x squared with a 0 coefficient, and take the highest power, divide, you will get a 3. So 3 into x cubed, 3 into 2x, this 0 remains as 0. And now change the sign and add. So now we are changing the sign and we are adding, we are left with -8. So now over here, the quotient is 3. The remainder is -8. So R is -8. Whether you write a plus sign and then -8 over here, or you take this negative on the outside, no issue. The divisor is this thing which is obtained by x into x squared plus 2, the original one. Now this minus sign is there. I'm including in this one -8 over this thing that has to be broken down into partial fractions. This is the quadratic. This is the linear factor. This is the quadratic factor. For the quadratic factor at the top, we write bx plus c or cx plus d. Use the constants that they have used. Do not change. So a is 3. That's already done. B, C, D. That is B and C and D. Take LCM. This gets multiplied with this. This gets multiplied with this. And then there is a certain way of solving this quadratic thing. So first of all, choose a value that will get rid of both of these. So that value is 0. So you get b is equals to -4. Now it so happens that this is something like x minus 1. So we choose 1, we get rid of these things. And the second value that we choose is 0. Now, whatever we have used, I cannot reuse it again. So now I'm stuck. Stuck in the sense that I have to solve it simultaneously. So now I'm choosing let x is equals to -1, plug in the value of b, form an equation, let x is equals to +2, 1, form an equation, 2, form an equation. So now over here, we are getting two equations. Let me just highlight them. This is the blue equation based upon x is equals to 1. This is the green equation based upon x is equals to 2. So now make solve it simultaneously. This is 2, this is 1. The equation was there, and then I made D the subject in both. So this is making D the subject. This is making D the subject. And then you solve, you find the value of C, you find the value of D. Yes, it so happens in that Cx plus D, maybe C could come out to be 0, maybe D could come out to be 0. Of course, both cannot be 0. So now we have this A, this is B over X, this is Cx plus D over X squared plus 2. So now these are the values that we find. So A is 3, and then B is -4, and then C is 4, C is 4, and then D is 0. That's how you find it. Now the question is technically about integration. This was a brush up of partial fraction. Everyone, I hope, is aware of partial fractions. So now what we do is that we integrate it. Now first take your time and decide on the integration technique. This is basic integration. This is rule number 1 of ln. This is rule number 2 of ln. So 4x, let's break it up into 2 into 2x. Why? Because the derivative of x squared is 2x. The derivative of 2 is 0. So I just need a 2x over here. So let's take that extra 2 on the outside. So this is 3 becomes 3x minus 4 as it is. Coefficient of x is 1. This is 1 over 1 ln x. And then this is 2 into ln of this thing. Then look at the simplification. I want you to have a look. The upper limit is 2, the lower limit is 1. So just have a good look at this. So now wherever there is x, you plug in the upper limit 2. Wherever there is x, you plug in the lower limit 1. Then there is a negative sign in the middle. Now focus over here. That is 3 into 2 is 6. And over here, 3 into 1 is 3. So these two are integers, pair them up. -4 ln 2. This is 2 ln 6. This is -4 ln 1. ln of 1 is 0. It's good. One term disappears. And this is 2 ln 3. So this is 4 ln 2, 2 ln 6, minus sign 2 ln 3. Now look at all the working. Again, make it the power. Leave the minus on the outside. This is positive. This is negative. This is negative. 6 square goes in the numerator. 2 power 4 and 3 square goes in the denominator. So 36 over 144, that's 1/4. I can leave the answer as it is. 1/4 can be written as 4 raised to power of -1. -1 will come out and divide, multiply, and have they given a particular format? Yes, they have given a particular format, so you have to get the answer in this form. That is, this thing is done. Something that involves, this is substitution. Let's go to substitution, also known as change of variable. The rule is change everything in x to everything in u. That includes the limits also. Now, always start with differentiation. So now over here, we have x power 5, where we have 1 plus x squared raised to power of 3 dx. And they have given us u as 1 plus x squared. So u is 1 plus x squared. Du by dx is 2x dx. Now, this x power 5, write x power 4 separately, x separately. So now this x dx is actually half du. So x dx is half du. Take the constant on the outside. Later on, there is no hurry. As long as you realize this thing, there is no hurry, you're all set. Now the remaining x power 4, I broke it up into x square. Why? Because if I make x square the subject, x square, I should have written over here, yes, x square is u minus 1. So x square is u minus 1, x square is u minus 1. This is already half du. The denominator is 1 plus x square cube, that is u cube. Now look at all the terms that you have. And yes, there is one other thing. What is that? That is the limits. And I have changed the limits over here. So u is 1 plus x square. When x is 0, u comes out to be 1. When x is 1, u comes out to be 2. Place limits where they belong. So lower limit is giving me lower limit, upper limit is giving me upper limit. Sometimes a small value gives you a bigger value gives you a small value. So for that thing, I have specifically written place limits where they belong. Now let's scroll up. And first thing, this thing was 3 marks. That is using the substitution, show that. Hence, find the exact value. Now, when we are solving something, we are in a mode that we keep on doing things. But again, it's a good idea and consider it compulsory to have a good look at it. That means stop where the first part was being asked. So now I don't have that space, but you will be having that space. So up till here was first part, that was 3 mark, including this limit thing that was in the first part. Now what you need to do is that take the half on the outside, multiply this out, that is u square minus 2u plus 1 divided by u cube. Simplify each term and then take these things on the top, except for this, because this will give you ln. So now decide. This is 1 over 1 ln u. This is basic integration. This is basic integration. And then what you need to do is that you need to first simplify. So negative 2 plus 1, negative 1, negative 2 plus 1, negative 1, this negative 1, negative 2, that makes it positive. Negative 3 plus 1, negative 2. This is power of negative 2, take it down. Once it's simplified, then plug in the limits. So that is the upper limit, it goes in place of u, u, u. And then the lower limit, it goes in place of u, u, and u. And then you just work with fractions, you work with ln, and then you get this answer. Let's move ahead. Now, let's talk about trig functions. Now, a comparison of differentiation and integration. Derivative of sine is cos. Derivative of cos is negative sine. Derivative of tangent is sec square. In other words, integral of cos is sine. Integral of cos is sine. Integral of negative sine is plus cos. Therefore, integral of only sine is negative cos. Integral of sec square is tangent. Differentiation, it's related with multiplication. Coefficient comes out and multiplies. Derivative of bracket comes out and multiplies. Integration, that is related with division. Some basic integration, you can have a good look. Sine 2x, that is half cos 2x. Integral of sine is negative. So differentiation, integration, be very, very vigilant, because sometimes people mix the two. Sometimes people mix product rule and integration by parts also. Case number 1, I'll just go through the cases quickly. Case number 1, that's integral of tan square x. You cannot integrate it directly. You need an identity, a simple square identity. 1 plus tan square is 6 square. So therefore, tan square is 6 square x minus 1. Integrate each term. 6 square x becomes tangent x. Minus 1 becomes minus 6. Tan square 2x, that is 6 square 2x minus 1. This is not a double angle identity. Whatever this angle is, that angle remains over here. When you integrate 6 square 2x, that is tangent 2x divided by 2. Second case, integral of tangent, integral of cot, write it as fraction, tangent sine over cos, cot cos over sine. Apply this rule of logs. If the numerator is derivative of denominator, integral is ln of denominator. Tangent, that is sine over cos. Is the derivative of cos sine? No, it's negative sine. So put a negative over there, balance it with a negative 1 on the outside. This thing fulfills the criteria. Numerator is derivative of denominator. So this is negative ln of cos x. Or if you want, make it the power. So cos raised to power of negative 1 becomes sec x. Cot x, that is cos over sine. Is cos the derivative of sine? Yes. So no adjustment, it's ln of sine x. Case number 3, case number 2, more examples. Tangent 2x, Sine 2x over cos 2x. Derivative of cos 2x is negative 2 sine 2x. Derivative. In order to balance this negative 2, put a negative half on the outside. Cot of 3x, that is cos of 3x over sine of 3x, is the derivative of sine 3x. This thing, no, 3 was missing. Put a 3, balance with a 1/3 ln sine of 3x. Case number 3, using double angle formula. Cos square x is half bracket 1 plus cos 2x. That's the process. From double angle, that's a revision of double angle also. Cos 2x, 2 cos square x minus 1, make cos square x the subject. Let me just put this equal properly and hold for a second. So now, no, I want to write it properly. Okay, that's good. And over here, cos 2x is 1 minus 2 sine square x, make sine square x the subject. That is what you get. Look at the two. It's half cos 2x and 1. It's half 1 and cos 2x. In sine squared, there is a minus sign. In cos square x, there is a plus sign. So remember these. Don't waste time in making it the subject on the spot. You already know this thing. It's half, it's 1, it's cos 2x, it's 1, it's cos 2x. Cos gives a plus, sine gives a negative. So you just have to interchange using this double angle. If this is x, this becomes 2x. If this is 2x, this becomes 4x. If this is 3x, this becomes 6x. If this is half x, this becomes x. And then work it out. So look at the first one. That is integral of cos square x. That is half bracket 1 plus cos 2x. First is the interchange. And then you integrate it also. So 1 becomes x, cos 2x. Integral of cos is positive. That's half sine 2x. Same goes for cos squared 2x. Cos squared 2x, that is half bracket 1 plus cos 4x. Integral of sine square x, half 1 minus cos 2x. Then integrate. Sine squared 3x, half 1 minus cos 6x. Very simple. Cos squared half x, half bracket 1 plus cos x. Case number 4, that is trig substitution, change of variable. Like we did algebraic substitution, this is trig substitution. So cos x over sin x, that thing, the cot thing, can also be done using change of variable. So the denominator is sin x. The numerator is at the top, that is cos x dx. So this is du over u, which is 1 over 1 ln of u, 1 over 1 ln of sin x. You can also do it this way. Similarly, tangent is sine over cos. U is cos x. Du is negative sin x dx. Therefore, sin x dx is negative du. Negative du. Let me just put this thing. Okay. So now over here, this is 1 over 1 ln u. And yes, there is this negative sign, which I skipped, minus ln u minus ln cos x, which can also be written as this. Now, sine square into cos x dx, choose u as the one trapped inside the power, not with the power, without the power. So u is sine x, du is equals to cos x dx. This is u squared du, that's u cube over 3 plus c, sine cube x over 3 plus c. Have a good look. Let's move on. Cos x over sine square x dx. So u is sine x, du is cos x dx. The derivative has to be in the numerator. It cannot be that dx in the numerator and there is something written over here. That's not possible. So this is 1 over u squared du. That is u raised to power of negative 2 du. That is u raised to power of negative 2 plus 1, negative 2 plus 1 plus c. Something to do with tangent and sec square. U is always tangent because the derivative of tangent is sec squared, not the other way around. So this becomes u cube du, that's u power 4 over 4 plus c, tan power 4x over 4 plus c. Tangent into sec square. U is again tangent, du is sec square. This is u du, u square over 2. I replace back u with tangent x. Trick in algebraic substitution. This will come in past paper question. Now, some questions that involved this thing, trig identity. So basically, I'm also revising trig identity over here. Okay, so trig is not done separately, but it's becoming part and parcel of differentiation equations. It's part and parcel of identity as part of integration and so on. Now, the first thing, this is like first simplify and then use the trig identity, things like that. So now let's look at the question. It says tangent 2 theta minus tan theta. That is tangent theta sec 2 theta. So let me write this out. Tangent 2 theta. So let me do a bit of coloring. Tangent 2 theta is written as sine 2 theta over cos 2 theta. Tangent theta is written as sine theta over cos theta. Now, what I did is that I took LCM. So this red multiplies with the blue, this blue multiplies with the red. So first of all, this is cos theta, this is sine theta, this is sine 2 theta, this is cos 2 theta. So now this is sine A cos B minus cos A sine B, just like one of the questions we did in differentiation. So this is sine A minus B, which is sine 2 theta. This is cos 2 theta at the bottom. This is cos theta. Sine over cos is tangent. 1 over cos 2 theta is sec 2 theta. It was a little bit out of the box. Now it's asking you to integrate between the limits 0 and pi by 6. So integral of this thing is actually integration of this thing. So now, first I replace it back. And now I have these two terms. That is tangent 2 theta. That is sine 2 theta over cos 2 theta. Then I have this thing, which is tangent theta, which is sine theta over cos theta. And then which technique am I using? I'm using this technique. That is if the numerator is the derivative of denominator. Sine 2 theta is a derivative of cos 2 theta. Almost. There is a negative 2 missing. Balance it with a negative half. So first write that, then start integration. Over here, cos theta, the derivative is negative sine theta. So write a negative, balance it with a negative. This sign remains as it is. So now let me just focus on this. This sign, negative, that remains as it is. The other things are adjustment. So integration is about taking one step at a time very, very carefully. This is negative half ln of cos 2 theta. This is negative 1 ln of cos theta. This negative becomes positive. So this negative is now positive because of this. And over here, the red thing, that is negative half ln cos theta. And this one was negative is already considered. And this is ln of cos theta. Okay. So now this thing is done. Then you plug in the limits. You take care of trigonometry. You have all these things over here. That is this thing. Cos of pi by 6, that is root 3 over 2. Cos of pi by 3, that is half. Cos of 0 is 1. Ln of 1 is 0. Everything is used over here for simplification. Even the rules of logs are used. Root 3 over 2. Can I write this root 2 as root 4? So root 3 over 4, I can take the square root as power half, take it outside. That is even used for simplification. And we need the answer in this exact form. In exact form was already there, but a particular form of this exact form. Now this thing is done. Another question which involves differentiation, integration. Prove that if y is equals to 1 over cos theta, then dy by d theta is sec theta tan theta. Y is 1 over cos, that can be written as cos raised to power of negative 1. Differentiate using chain rule. Negative 1 comes down, cos remains as it is, power reduces by 1. Derivative of bracket is sine theta. So now this thing is done. Then it says if the derivative of sec is this thing, then the integral of this thing should be sec. That will be used up later. Now the second identity, 1 plus sine, 1 minus sine is 2 sec square plus 2 sec tan minus 1. So now this one was again out of the box. 1 plus sine divided by 1 minus sine, that is 2 sec squared, 2 sec theta, tan theta minus 1. The left hand side, divide numerator and denominator by 1 plus sine theta. So now 1 plus sine theta over 1 plus sine theta divided by 1 minus sine theta over 1 plus sine theta. So therefore, this is this thing. And this division, let's change it into multiplication. So therefore, over here, this is a plus b, this is a plus b, this is a squared plus b, a squared plus 2ab plus b squared. This is 1 plus sine, 1 minus sine, this which is 1 minus sine squared, and then you divide. And look at the working. So it was not an easy working. Okay, so this was a little bit out of the box. In such a question, if you come across this kind of difficulty level, I would advise you, leave it, come back to it at the end rather than fighting over it, being stubborn over it and destroying the rest of the working. So do this thing. Yes, definitely it was out of the box. So now we have this thing. And then it says, hence find the exact value. So you have already proved, look at part 2. You have already proved that this thing equals to this. So integral of this thing is actually integral of this thing. So 2 sec square theta, integral of sec square is tangent. 2 times sec theta tan theta, that is related with part 1. So integral of this thing is 1 over cos is sec. So your choice, write it as sec. Your choice, write it as 1 over cos. Minus 1, that is also direct. Minus 1 becomes minus theta. That is the main story over here. The plugging in was not that difficult. Tangent of pi by 4 is 1. Cos of pi by 4 is 1 over root 2. Since I have to flip it, that's why I use the unrationalized form. Otherwise, normally I use the rationalized form. And this is the answer. Now let's look at this one. The case 4 of integration. Hold for a second. Yes, a compound rule thing. Let's look at this because again, this is related with trigonometry. It says express cos theta plus 2 sine theta in the form r cos theta minus alpha, where r is positive, alpha is acute. Give the exact value of r and tan alpha. So now the rule is if it starts with a cos and converts to cos, the first coefficient is a. That's the way I have taught it. The second coefficient is b. Some people do it by comparing coefficient. Good for them. So now over here, a is 1, b is 2. R is a square plus b square under root, Pythagoras theorem, but only take the positive value. Alpha, the basic angle, not the basic angle for the trigonometry, the angle over here, that is tangent alpha is second coefficient over the first coefficient. And I have written the value of tan alpha. Have they asked for tan alpha or alpha? Give the values of r and tangent alpha. Otherwise, alpha is tan inverse of 2. Now it says, hence showing all necessary working, show that the integral of this thing is 5. Exact answer. Now, first of all, you plug this thing over here. You don't know alpha. I know that. Wait, hold, have some patience. First, square it. So root 5 square becomes 5. This is cos square theta minus alpha. 1 over cos square theta minus alpha is 6 square theta minus alpha. This 15 over 5, that becomes a 3. Integral of sec square becomes tangent. Now the real game starts. When we plug in this value, that's where you have to do the evaluation. So now tangent of pi over 4 minus alpha, that I have done it over here in 2 different ways. Tangent A minus B, that is tangent A minus tangent B, 1 plus tangent A tangent B, not 2 different ways, 2 different things that we have done. So tangent pi by 4 minus alpha based upon this comes out to be minus 1/3. Tangent 0 minus alpha, I could have written also directly tangent of negative alpha is negative tan alpha. I have written it over here. But if I want to use it using the addition formula, tangent 0, tangent alpha, 1 minus tangent 0, tangent alpha like this, still you get the same answer. So the right answer, that is negative 1/3. That is based upon this thing. And the blue answer, that is -2. And that's how beautifully this thing is done, giving you an exact value. Amazing questions that I have solved over here. Something like this. Sine 3x, that is sine 2x plus x, and they are asking us to prove this identity. So another trigonometry identity that I'm solving for you people. Sine 2x plus x, that is sine 2x cos 2x sine x. Sine 2x, write this thing as 2 sine x cos x. There is no issue with that. Cos 2x, write this thing as 1 minus 2 sine square x, because you want everything in sine. Then when you expand it, the only thing that's not sine, it's cos square. But let's replace it with 1 minus sine square. And now there is everything in terms of sine. So basically, you have proven that sine 3x is equals to 3 sine x minus 4 sine cube x. That means if they want me to integrate sine cube x, so I can make it the subject. And that would be sine 3x minus 3 sine x divided by -4. So that is what I've done on the next page. And the minus sign will change the position of these two. So this is 3 sine x minus sine 3x over this thing. This is 4 sine cube x is 3 sine x. Okay, I have already shifted to the other side. So therefore, this is 1/4 3 sine x minus sine 3x, direct, plug in the limits, and then you get this answer. So what are the limits? And even before that, I have done some more simplification. I have taken LCM, I have taken this 3 on the outside, and then afterwards I plugged in the limits. So we have the upper limit, that is pi by 3. So 3 into pi by 3 is pi, and this pi by 3 remains. And this is the lower limit 0. Don't always assume that it will give you 0, because cos of 0 is 1, cos of 0 is 1. And then you simplify and you get this answer. Let's focus on a question like this, which is a combination of a change of variable in terms of trigonometry. Now this is written in x, we are converting it into theta. So now 0 till 1, 9 over 3 plus x square dx. And what we do over here is that we use the substitution that they have given. So that substitution is this thing, use x is equals to square root of 3 tan theta, square root 3 tangent of theta. So we will start with dx. We will change the denominator. We will change the limits. This is a constant. This is a square. X is root 3 tan theta. Dx is root 3 sec square theta d theta. If I make x the subject, x is already the subject, let's square both sides. So x square is there. So that is needed over here, the green one. Change the limits. When x is 0, tangent of theta is 0, theta is 0. When x is 1, tangent of theta is 1 over root 3, theta is pi by 6. Okay, now over here, change everything. So now this dx, that is replaced with this thing. 3 plus x square is replaced with 3 plus 3 tan square theta. There is a square on the outside. The limits are changed, 0 and pi by 6. Now look at the working over here. So now this is 9. This is root 3 sec square theta d theta. 3 common, 1 plus tan square theta. So this is 3 common. 1 plus tan square theta, this is sec square theta. It's being squared. So 9, this is 3 square, that becomes 9. I'm writing sec square theta twice. Let me cancel this sec square with this sec square. 9 and 9 cancel. Root 3 over sec square. Root 3 on the outside. 1 over sec square is cos square theta, and then use double angle over here. That is half 1 plus cos 2 theta. First use, then integrate, then plug in the limits, simplify, and you get this answer. Now let's talk about integration by parts, some examples of integration by parts. That is over here. It is a product of two functions. There is algebra, there is exponential. It could be algebra and trig. It could be algebra and logs. It could be constant 1 and logs, actually logs all alone. And it could be exponential and trig. The rule is choose u as something which you are able to differentiate easily and which finishes in the long run. That is why in most cases, u is chosen as the algebraic part. And what about dv? dv is chosen such that it can be integrated. So basically, the decision is about u, dv comes naturally. And then we apply this concept that is of late, LATE. L for log, A for algebra, T for trick, E for exponential. This is the order for choosing u. So this is order for choosing, and I did not write over here. That is u. That's the order for choosing u. Exponential integration, just a review because it was not done earlier. That is this thing, which is e raised to power of ax plus b. And this function remains as it is. Power comes down and divides. So now let me write over here. Power comes down and divides. And this is derivative of power. Derivative of power comes down and divides. So this is the derivative. This is the power. That is the derivative of the power. E raised to power of x, that is 1 over 1 e raised to power of x. E raised to power of 2x, derivative is 2x. So derivative is 2x, 2 comes out and divides. Derivative is 1. Very important rule used over here. E raised to power of 3x dx, the limits are 0 and ln 2. It's e raised to power of 3x divided by 3, 0 and ln 2. So now let me first plug in the upper limit, that is ln 2. Then let me plug in the lower limit, that is 0. So now 3 ln 2 is actually ln 2 cube, which is ln 8. E raised to power of ln 8 is 8 based upon this rule. Very important. E raised to power of ln x is x, provided x is greater than 0. E raised to power of 0 is 1. So you're getting an exact answer, which is over here. Now, if I have exponential in algebra and exponential, I'll choose u to be x, du is 1 dx, dv is ex dx. Whatever is left, that is ex dx. So therefore, v is ex. Follow the rule, that is u v minus integral v du. So this is u v minus integral v du. That is how we do it. If there is one term left, just integrate it directly. Overall constant of integration at the end. If you have algebra and trig, u is still algebra. If you have algebra and log, now the tables are turned. So u is ln x, du is 1 over x dx, dv is x, v is half x square. So half x square into ln x, that goes over here. And 1 over x into half x square, that is x over 2. Integrate it and you get this. Something like ln x all alone. So u is ln x, du is 1 over x dx, dv is 1 dx, v is equals to x. So ln x into x, that is x ln x minus 1 dx. One integration will give me x. If you have a power of x as 2, it will take 2 steps. U is x square, du is 2x dx. dv is ex dx, v is ex. So after the first step, you still have a product on the inside. Follow the same rule. U is still algebraic. U was still algebraic. So let me focus over here. U was algebraic. U is still algebraic. dv was exponential. dv was exponential. dv is still exponential. So that you follow. Now keep in mind, this whole box is this thing over here, correct? So now put a big bracket and then simplify. So this is 2x ex minus 2ex. This is now directly done. And then look at the progression. That is like x squared. There is 2x. The 2x derivative is 2. So x power 1, 1 step. X power 2, 2 steps. Something like exponential and trig function, they haven't ever asked this, but of course it's part of the syllabus, so we should study. Doesn't make a difference what you take as u, whether you take trig as u, whether you take exponential as u. Officially, it's written as late, but I prefer this one. U is ex, du is ex dx, dv is sine x dx, integral of sine x is negative cos. So now this is ex into negative cos x, ex into negative cos x. This negative becomes a positive. This is ex cos x. Again, whatever you have chosen as u should be chosen in the next step also. Whatever category you have chosen as dv, that should be dv in the next step also. So u is exponential, dv is trig. So now again over here, derivative of ex is ex, integral of cos is positive sign, follow the arrows, and now it so happens that this thing that you are getting isn't that the question which with you started. Maybe there is a constant that you can take common. So let m equals to this. So this is m, this is negative m. Take the m to the other side. So m plus m is all this thing. Put a constant on the very end. Don't worry much about the constant. So 2m is equals to this. So divide by 2, and write a constant of integration. So now integration is all done and dusted. Let's move to differential equation. And let's directly move to the questions. So now this is 1023. We are on the last one. So the last topic is now differential equation. So DFEQ. DFEQ, that is differential equation. This is word problem of integration. Word problem of integration. That is what I call it. Okay. So now over here, the variables x and y, they satisfy this differential equation. It is given that y is 2 when x is 1. Solve the differential equation. Now, every single technique of integration will be used over here, whether it's P1, whether it's P3, whether it's integration by parts, whether it's trigonometry, whether it's tan inverse, anything, everything can be used over here. So now over here, we have this thing, 1 over y. So the rule is take all the y terms to the left-hand side. So now over here, let me choose this thing. This dy will go with y. So this dy will go with y. And then we have this dx will go with all the x terms. So x plus 2, x plus 1, dx. This is called separating the variable. Now, before we proceed, first look on the left-hand side. Can it be integrated? Yes, it will give us ln. Can it be integrated in this form? The answer is no. This is not a partial fraction because there is only one thing in the denominator. So it's not direct ln because there is not a constant at the top. If this was x squared and this was 2x or just x without this constant, that could have been done. So first you need to simplify using algebra because the powers are equal. So x plus 2 over x plus 1 is 1. Quotient, remainder is 1. So this is quotient, remainder, divisor. This is quotient, remainder, divisor. Now can you integrate it? Yes. This is direct. This will give me ln. This will give me ln. Now when you have many terms of ln, so you can write the constant c separately, or instead of c, let's write ln a. Doesn't make a difference. A is a constant. So ln of a constant, still a constant. So now 1 over 1 ln y, this is x, this is 1 over 1 ln x plus 1. The 1 over here is because of the coefficient of y. The 1 over here is because of the coefficient of x. So now what I have done is that since ln is base e, I have written this as x ln e, which can be written as ln e power x. So positive, positive, positive. So ex, x plus 1 into a, they all multiply like this, and this is ln of y. So now y is equals to aex, x plus 1. Plug in the condition. Now this is called a general solution. When you plug in the conditions, the x and y coordinates, you find the value of the unknown constant, which is 1 over e. Replace it back, you find y in terms of x. If it asks you to find an expression for y in terms of x, you will do it. Otherwise, you would leave it as a raw form, just a bit simplified. Something like this involves partial fraction. So 1 over 4 minus y square in partial fractions. So 4 minus y square is 2 plus y, 2 minus y. 1 over 2 plus y, 2 minus y, you do the partial fraction, the simple linear case. You take the LCM, you find the unknown constants. This comes out to be 1/4, this comes out to be 1/4. Now take this 1/4 and push it on the outside. The variables x and y satisfy this differential equation. So now how is it supposed to be done? There is y over here. There is 4 minus y square over here. This is 4 minus y square. This is dy. The partial fraction was already done. This one is x over here. This one is dx over here. Take it to the other side. So this is 1 over x dx. Now, before you start integration, again simplify. So this was done in part 1. 1/4 is taken common. 1 over 2 plus y, 1 over 2 minus. The second most important thing is that the coefficient of y is -1. Depend and also focus on the technique of integration. 1 over ax plus b dx, that's 1 over a ln ax plus b plus c. So this is 1/4. This is 1 over 1 ln 2 plus y. This is 1 over -1 ln 2 minus y. 1/4 is common because of the negative sign. This is division. This is 1 over 1 ln x plus ln a. Now all the terms were in ln. So now make it this the power, or take this 4 on the other side. That is what I've done. And then I made this the power. Doesn't make a difference. So now ln of something, therefore this something and something is equal. A power 4, I have written it as b. Now we sometimes write e to the power c as a, sometimes we write 2c as d, sometimes we write a power 4 as b, so it doesn't make a difference. So 2 plus y, 2 minus y is b x power 4. When y is 1, x is 1, find the value of b, that is 3. And then it's basic maths, that is making something the subject. Now people ask this question, what about the knowledge of O-level maths? So this is knowledge of O-level maths applied in A-level second year in P3. That is making something the subject of the equation. So subject of the equation, that is why it's so important. Got the idea? Again, partial fraction type. Let me look for something different. This is also the same partial fraction type. Yes, this part I want to focus on. So let me go through the whole question. So now over here, the variables x and t satisfy this differential equation. 5 dx by dt is 20 minus x, 40 minus x. It is given that x is 10 when t is 0. Use partial fraction, solve the differential equation, obtaining an expression for x in terms of t, 9 marks. What happens to the value of x as t becomes very large? So now what do we have? We have this thing over here. Let me again use this thing. This is dt. This is all alone. And this 5 I'm taking to the other side. Over here, the x, there is dx, that is 20 minus x, 40 minus x. That is 20 minus x, 40 minus x, and dx. Now partial fraction is used over here. So now the partial fraction working was done earlier over here. That is the simple partial fraction working linear case. And again, like 1/4 was taken common. So over here, 1 over 20 is taken common. The coefficient of x is negative. The coefficient of x is negative. There is a negative sign in the middle. Keep that in mind. Okay. And let's proceed. So this is 1 over 20 as it is. Actually, I took 1 over 20 to the other side. 20 over 5 is 4. This is 1 over -1 ln 20 minus x. This is negative. This is 1 over -1 ln 40 minus x. So now this is positive. This is negative. This becomes the numerator. This becomes the denominator. Got the idea? So this becomes the numerator. And this becomes the denominator. That's how it's done. And this is 4t plus c. And then what do? We make ln till exponential. So ln of something means base e. So base raised to a power, base raised to power is equals to this. e raised to power of 4t, e raised to power of c, let e raised to power of c equals to a. So now this is simplified. Plug in the condition with x is 10, t is 0. You get a to be 3. And then you get this thing over here. 40 minus x is this much, make this the subject, everything, and that you get this thing. Now remember these important rules. That is 0 divided by any number is 0. Any number divided by 0 is undefined. And if I cross multiply, so any number divided by undefined is 0, and there is a new thing also. That is k infinity over infinity, infinity cancels. We are left with the k. Why do we need it? X is this thing over here. If t becomes very large, so e raised to power of this thing will become infinity. This is also infinity. Addition, subtraction won't make a change. 60 divided by 3, that gives me 20. That is based upon this rule. So addition, subtraction, it's like a drop in the ocean. That won't make a difference at all. So the difference is made by this thing, 60 infinity over 3 infinity. So infinity cancel. 60 over 3 is 2. That is for the knowledge of P3. That's more than enough knowledge that we need. Let me just first look at the different questions. Something that involves trigonometry. Okay. Now over here, look at this. It says the variable x and theta satisfy the differential equation 3 plus cos 2 theta d theta sine 2 theta all on one side. Dx and x on the other side. This is simple. Now over here, we are applying this rule. Both are applications of integration, technique of integration that gives me ln. This is the basic one, 1 over ax plus b. That is 1 over a ln ax plus b. That is applied to the left-hand side. Numerator is derivative of denominator. 3 plus cos 2 theta, derivative of 3 is 0. Derivative of cos 2 theta is negative 2 sine 2 theta. This was the missing piece of the puzzle. You write a negative 2, balance it with a negative half. So this is 1 over 1 ln x. This is negative half ln of the denominator. And then I write ln a. And then this is negative, this is positive. So this numerator, this is denominator, ln cancels in the common layman's term. As such, they don't cancel. We apply this knowledge that is over here, which is if I say log m base a, if it equals log n base a, therefore m is equals to n. That is the knowledge that is used over here. So m, and this is n. So m equals to n, that is the knowledge. So this is n, and this one, the green one, is this thing. That is how this thing is applied. This is x, and this whole thing is the origin. Okay. Then we plug in the condition, the x and y values, the x and theta values, that's the condition. We find the value of a. We make x the subject. We do a little bit of simplification, some surds and things like that. That is what you get. Now over here, they're also asking, find the least value taken by x. Now they are asking us in terms of trigonometry. So now this is based upon cos. Maxima minima, that is related with differentiation, but maxima minima is also related with trigonometry. So the cosine maximum value is 1, irrespective of what the angle is. Cosine minimum value is negative 1. If they ask for the maximum, I can use 1, I can use negative 1, but keep in mind it's in the denominator. So if the denominator is bigger, whole fraction is smaller. So if I plug in 1, I'll get a least value. If I plug in negative 1, I'll get a greater value. So I need the least value. So that was the trick in this. And this is the same kind. I'm looking for something else. Something to do with exponential. The variables x and y satisfy the differential equation. So this is, let me highlight it. So dy and e raised to power of negative 2y. That becomes e raised to power of 2y dy. and the other one that is tan square x and dx. So tan square x, I have written it as sec square x minus 1 into dx. Tan square x dx, and the original one before simplification, that is e raised to power of 2y dy. So now both things are simplified. Remember, we studied this case. How do you integrate tan square? 1 plus tan square is 6 square. So tan square is 6 square x minus. And this has to be taken up before you integrate. So once you integrate this 1 over 2 e raised to power of 2y, integral of 6 square, that is tangent, integral of 1 is x plus c. Plug in the condition, x is 0, y is 0. We get c is equals to negative half. You write it down. Are they asking us to make the subject? No. Solve the differential equation. That means after plugging in the value, get the particular solution, calculate the value of y when x is 1/4 pi. So when x is pi by 4, y is this. Just simplify, of course, use a calculator and then get the answer. So I think that is about it from my side. So differential equation is also done and dusted. And now tomorrow, inshallah ta'ala, we will be starting day 2. We will first do, let me also tell you the order in which I'll proceed. First, I'll deal with complex numbers. Then I'll discuss vectors. Then I'll talk about numerical solution of equations. And then maybe a bit of trigonometry. And actually, that would be dealt with in numerical solution. And it was dealt today also, maybe a little bit more. That is this thing, and a bit of binomial. So now that is the basic idea for tomorrow. So see you tomorrow, inshallah. Take care, everyone. Allah Hafiz.